Hello, good evening guys. My name is Sakshi Annara Dalgade. College name is Sri Siddheshwar Women's College of Engineering Solapur. Name of the branch is Computer Science and Engineering. Year first year. Today's we talking about a linear algebraic matrix. In this we learn a matrix and eigenvalue and eigenvector. What is the matrix? A system of a m n number arranged in the form of a rectangular array having m rows and n columns is called as the matrix of a order m into n. Example, row 9 5 3 5. The general form of a 3 into 3 matrix is a row A11, A21, A31, row 2 A12, A22, A32, row 3 A13, A23, A33, bracket close 3 into 3. The matrix are always denoted by the capital letter. First, row matrix. A matrix have only one row and more than one column is called as row matrix. Example, bracket 3 2 1, bracket close 1 into 3. Column matrix. A matrix having only one column and more than one row is called as column matrix. Example, A is equal to A11, A21, A31. Null or primary matrix. A matrix each element of which is a 0 is called as null matrix. 0 0 0 0 0 0 3 into 2. And second example is column 1 0 0 0, column 2 0 0 0, column 3 0 0 0, 3 into 3. Then square matrix. A square matrix is a matrix that has n equal numbers of rows and columns. In mathematics, m into n matrix is called as the square matrix. Example, row 2 5 6, second row, minus 7 8 6, third row, 5 6 0, bracket close, 3 into 3. Singular matrix. A square matrix is said to be singular if determined A is equal to 0, otherwise A is not equal to 0. Row 1 4, row 2 2 8. Diagonal matrix. A matrix then has all elements as 0 except diagonal element is known as the diagonal matrix. Row 1 8 0 0, row 2 0 4 0, row 3 0 0 4, bracket close 3 into 3. Eigenvalue and eigenvector. Eigenvalues are associated with the eigenvector is a linear algebra. Both terms are used in the analysis of a linear transformation. Eigenvalues are the special set of the scalar values that is associated with the set of a linear equation, most probably in the matrix equation. It is a non-zero vector that can be changed at most by its scalar factors. After the application of a linear transformation and the corresponding factors which scales that the eigenvectors is called as the eigenvalue. Produces of a eigenvalues. Let A is equals to row 1, A1, A2, A3, row 2, B1, B2, B3, row 3, C1, C2, C3. I is equals to row 1, 1 0 0, row 2 0 1 0, row 3 0 0 1. A minus lambda I is equals to row 1 A1 A2 A3, row 2 B1 B2 B3, row 3 C1 C2 C3 minus lambda row 1 1 0 0 0 1 0 0 0 1. Then is equals to row 1 A1 A2 A3, B1 B2 B3, C1 C2 C3 minus lambda 0 0 0 lambda 0 0 0 lambda. Then is equals to row 1 a1 minus lambda a2 a3, row 2 b1 b2 minus lambda b3, row 3 c1 c2 c3 minus lambda. On simply we get in general a cubic equation lambda cube minus s1 lambda square minus a is equals to 0, where s1 is equals to sum of a principal diagonal element of a matrix A s1 is equals to a1 plus b2 plus c3. S2 is equals to minor of a a1 plus minor of a b2 plus minor of a c3. S2 is equals to b2 c2 c3 c3 plus a1 c1 a3 c3 plus a1 b1 c2 b2. Then lambda cube minus 8 lambda square plus 7 lambda minus 11 is equals to 0. Then answer lambda is equals to 289. We get a cubic equation solving. We get 3 values of a lambda. Produces of a eigenvector. Consider lambda, they have exist a non-zero column vector y is equals to xyz is called as the eigenvalues. To determine the eigenvectors, consider metric equation is a minus lambda I is equals to 0. Then take a dot dot 0. Solve the set of a homogeneous equation to the get solution. Example first. Find the eigenvalues and the eigenvector of the matrix is A is equals to row 1 1 0 0, row 2 2 2 0, row 3 3 6 minus 3. The characteristics of the equation is A minus lambda I is equals to 0, row 1 1 0 0, row 2 2 2 0, row 3 3 6 minus 3 is equals to 0. Thus simplifying the general we get lambda cube minus s1 lambda square plus s2 lambda minus a is equals to 0, where s1 is equals to 1 minus 2 minus 3 is equals to minus 4. Then s2 is equals to row minus 2 0, row 2 0 6 plus 1 0 3 minus 3 plus 1 0 2 minus 2. Then is equals to 6 minus 3 minus 2 is equals to 1. A is equals to 1 bracket 6 bracket close minus 2 0 plus 3 is equals to 6. Equation 1. Lambda cube minus 4 lambda square plus lambda minus 6 is equals to 0. Roots are 1 minus 2 minus 3. Then answer will be lambda is equals to 1 minus 2 minus 3. Eigenvalues are 1 minus 2 minus 3. Let x is equals to 1 x1 plus x2 plus x3 be the eigenvectors of corresponding to the eigenvalue lambda into x is equals to 0. Then row 1 1 minus lambda 0 0, row 2 2 minus lambda 0. Then row 3 3 6 minus 3 minus lambda bracket close x y z is equals to 0. Case 1 let case 1 let lambda is equals to 1. Equation A becomes row 1 0 0 0, row 2 2 minus 3 0, row 3 3 6 minus 4 bracket close x1 x2 x3 is equals to 0. Then 0 x1 plus 2 x2 plus 3 x3 is equals to 0. 0 into 1 0 minus x3 minus x2 plus 6 x3 is equals to 0. 0 x1 plus 0 x2 minus 4 into 3 is equals to 0. Form equation A and B. x1 is equals to minus x2 is equals to x3. Then 2 minus 3, 3, 6. 0, 0, 3, 6. 0, 0, 2 minus 3. x1 by x 21 is equals to x2 by 0, x is equals to x3 by 0. Then x1 by 1 is equals to x2 by 0 is equals to x2 by 0. Then for for lambda is equals to 1, x1, x2, x3 is equals to 1, 0, 0. Case 2. Let lambda is equals to minus 2. Equation A is equals to row 1, 3, 0, 0, row 2, 2, 0, 0, row 3, 3, 6 minus 1. x1, x2, x3 is equals to 0. Then 3x minus 3x1 plus 2x2 plus 3x3 is equals to 0. 0x1 plus 0x2 plus 6x3 is equals to 0. 0x1 plus 0x2 minus 1x3 is equals to 0. From equation x1 is equals to minus x2 is equals to x3. Row 1, 2, 0, row 2, 3, 6, 3, 0, 3, 6, 3, 2, 3, 0, 2, 0. x1 by 12 is equals to x2 by 18 is equals to x2 by 0. x1 by 2 is equals to x2 by minus 3 is equals to x2 by 0. Then for lambda is equals to 1, x1, x2, x3 is equals to 2 minus 3, 0. Case 3. Let lambda is equals to minus 3, row 1, 4, 0, 0, row 2, 2, 1, 0, row 3, 3, 6, 0, x1, x2, x3 is equals to 0. Then 4x1 plus 2x2 plus 3x3 is equals to 0. 0x1 plus 0x2 plus 0x3 is equals to 0. 0x1 plus 0x2 minus 0x3 is equals to 0. From equation x1 is equals to minus x2 is equals to x3. Row 1, 2, 1, row 2, 3, 6. Row 1, 4, 0, row 2, 3, 6. Row 1, 4, 1, row 2, 2, 0. x1 by 9 is equals to x2 by minus 24 is equals to x2 by 4. x1 for lambda is equals to 1, x1, x2, x3 is equals to 9 minus 24, 4. Therefore, eigenvectors are 1, 0, 0, 2 minus 3, 0, 9 minus 24, 4. Now I completed my all topics. Hope you will enjoy my video. Thank you.